Okay, we are now being recorded, so say nice things. All right, hey you guys, on this one right here, it was a quadratic function, so we had an x squared was a parent function. Replacing x with x minus 4 moved it 4 places to the right. Adding 2 to the function moved it up 2. Okay, so that is the correct answer there. And then on number 2, it was an absolute value function, which we used. Makes this shape right here. The x plus 2 would move it left 2 units, up 2 units, the vertex, and the minus 3 moves it down 3 units. And so that is the correct answer there. Okay, now I want to answer questions on your. Wait, I want to see if anybody got the number 8 on the back. I want to see the challenge problem. Sean got it? Anybody else? Let me see what you got. That's pretty darn close. What do you have in there? That's interesting. Yeah, that would work though. I mean, it's close, but it's close, but no cigar. All right. Sean, what did you have? Anybody else think they got it? Hey, what? Okay, that one looks like, I'm going to pull up that one looks like this, doesn't it? Doesn't it? Let's see if I remember what it looks like right here. It's like this. Isn't it like that? Okay. Oh, it goes up to 4 in the middle? Okay. So it's going up like this. You guys, does anybody see? I told you this was a combination of 2 functions that we've talked about, right? Which two functions do you think it might be? Yes, that is correct. If you guys think about this, a parabola looks like that. See this part right here, the part that reflected back up over the x-axis? It just came from a quadratic function. And how did it reflect up there? Sean? That is correct. Yeah, whenever you take the absolute value of something like that, the values are going to be positive, right? And so what did you get for the answer? That is the correct answer right there. It's just, you guys, x squared minus 4. I'm going to erase this so you can see it. X squared minus 4 would look like this function right here, where it just moved it down 4 units, right? So it would look something like this. A parabola looked like that. I made it a little bit too sharp on the vertex. But then all it does is it takes the part that's below the x-axis and it reflects it up over the y-axis, so you get this right here when you take the absolute value of it. All the y values that came out to be negative, when you took the absolute value of them, became positive. So that's the function right there. Good job, Sean. All right. Any others you want to ask questions about? What? Yeah, since you weren't here, I'll let you do that. Anybody else? How many of you got it all done? Good. Yeah, well, you can finish up during class and just put it on there when you're done, okay? All right. Yes, Kaylani. You drew the general shape?
On the graphing thing, like I didn't like exactly like go to like the exact points. I just kind of, you know what I mean?
Okay, well,
It's a general idea.
you guys, on 1 through 9 at the bottom of the page right here, what I wanted you to do is guess what the function would look like, and then put it in your calculator to see how close you were, and then just put the correct one afterwards. Okay?
You wanted us to,
I wanted you to guess what you thought it would look like, and graph it on there.
I thought it was
and then put it in your calculator and graph it, and then put the correct one on there so you can see what you did wrong. Okay? So that's what I want you to do. I mean, got that. All right. Let me just quiz you on a couple more. Did you guys get on number 4? Yeah. Okay, we're going to do quiz trade. For the test review. Okay, problem number 1. Problem number 1. Okay. What would the new function be if you wanted y equals x cubed to move left 2 units and down 5 units? Okay, I'll give you a few seconds to work on that. All right, show me your answers. You guys, let's see what you have. Oh wait, actually, let's spin. I don't want to look at every board in here. Okay, person number 1, show me what you have. Correct, 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 and correct. Okay, you guys, if I want to move the new function, x cubed, I wanted to move it, what did it say? 2 units to the left, I would replace x with x plus 2, right? And then it's a cubic function, so it's cubed. And then down 5 units would be minus 5. And I think you guys all had that one correct. Okay? Do you understand what it's asking? Okay. Problem number 2. Okay. Is this function continuous? Is this function continuous? I'm going to give you a minute to think about that. You can look in your notes if you need to. Is this function continuous? Okay, we're spinning. Okay, person 4 in each group. If you have 3, person 3. Show me what you have. Okay, that is the correct answer, but I want to know why. Okay, yep, that's why. Good job. That's the wrong answer. Yes. I couldn't see your reason very well. Okay. You guys, why is this continuous? It is continuous. Why is it continuous? Yeah. Are there any holes in it? No. Are there any asymptotes in it? No. Could you draw the whole thing without lifting your pencil? Yeah, if you could go on forever, right? So yes, this one is continuous. It goes on forever in all directions. By the way, this is a cubic function. It would look something like this. But you can draw this without ever lifting your pencil. Okay, and that's what we mean by continuous. Third problem right here. Is this one continuous? Let's go like this. Is this one continuous? Show me what you have. Person 3. Okay, but yeah, that's the correct answer. Good. Okay, good. 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 You guys, some of you guys are talking about the denominator, but why is it not continuous? I mean, I think the only person that put it right, who was that over there that had that over there? Michaela. Yeah. There is no, what'd you put? There is an asymptote at x equals -1, right? Okay, yeah, if you guys put, you'll notice x cannot be -1 because -1 plus 1 would make this undefined. In other words, there's an asymptote at -1. So if I was to graph this function right at -1, there is an asymptote. So this graph is never going to cross. This graph looks something like this if you graph it in a calculator. And it's never going to cross it. And so you'd have to lift your pencil to draw the two parts of that, right? It's not continuous. All right, problem number 4. What is the end behavior? Of y equals 5x squared plus 2x minus 8. What is the end behavior of that function? Let's spin the spinner. Problem, person 2. Show me what you have right here. Person 2. I believe that's correct. Yeah. Wow, you guys are doing it very, I like the way you guys are doing it. It makes it harder for me to read it. I have to think about it, so. As x approaches. And yeah, that's correct. Good job. Okay. Okay, I probably need to write it a little bit different than that. You got the second one wrong on that one. Okay. All right. Hey, you guys, look. If you graph this function, is that okay? That's this one right there. Yeah, I don't know which way this one shifts, you guys, but let's say it shifted over here somewhere like that. All I know is that since it's an x squared, I know it's a parabola, right? And since the coefficient of x squared is 5, which is a positive number, I know it's opening up, right? So when I say what is the end behavior, I'm asking as x goes to positive infinity, as x approaches positive infinity, what is y doing? Y is going up as well. It's not going down, right? You got two choices for y. It's either going up or down. Well, it's going up forever, so we say y is approaching positive infinity. Got it? And so you can write it like that. And the next one right here, as x approaches negative infinity, that means as x goes in the negative direction towards the left, then y is approaching positive infinity. Y is approaching positive infinity. Okay? And so we would say that. The other way you could write it is it's going up to the left and up to the right. I would want you guys to know this notation because this is what you're going to have to understand when you get to calculus. But as you know it's going up to the left and up to the right, then you've got it. Okay? Next one. It's kind of like this one. End behavior here again. Let's do this one. What number are we on, by the way? End behavior. Number 5 of y equals negative 6x cubed plus 2x squared minus 6x plus 1. What is the end behavior of that function right there? The cubic function is going up like this, right? So it's going up to the right and down to the left, but that's only if the coefficient is positive, right? Well, what's the coefficient here, you guys? Negative. So this one is going up to the left, and down to the right. Now I want you to write that in that other notation. See if you can write it in the other notation. Guys, remember, if this power right here is odd, it's going adding, and this is what you were asking. If this is odd number right here, the power, then it's going up one way and down the other way, okay? If it's even, it's going both up or both down. And then the coefficient, if it's positive, it tells you it's going in one direction. If it's negative, it goes in the other direction. You guys know a parabola opens up if it's a positive coefficient, right? Opens down if it's a negative coefficient. And the normal way for a cubic function to open up is up to the right and down to the left. So if it's negative, it's going to go opposite of that. All right. Who haven't I chosen yet? Has everybody gone at least once? Let's do it person number one anyway. We haven't done person number one for a while. Okay, as x approaches negative infinity, y approaches infinity, and as x approaches infinity, y approaches negative infinity. That would be right there. Okay, as x approaches positive infinity, negative infinity, positive infinity. That's right. Okay, all right. I'm just going to write it down. This takes too long to write this way, you guys. Okay, it's this one right here, right? As y approaches positive infinity, no, as x approaches positive infinity, right? Because we're talking about what the x is. As x approaches positive infinity, y approaches negative infinity, right? Because it's going down. As you move right, the function is going down. Okay, right here again. As x approaches negative infinity, that means as it goes left, y approaches positive infinity. So the first one up here, you guys, as x approaches positive infinity means as x goes to the right, y approaches negative infinity. That means y value is going down. And the next part, as x approaches negative infinity, that means to the left, y approaches positive infinity. That means it's going up. Got it? All right, I'm just going to talk about one for just a second. What if I gave you something like this? Y equals 3, negative 3x to the 4th plus 6x cubed minus 7x squared plus 5x minus 10. What's the only thing you have to worry about on here? The very first term. Why? It's the biggest term. So all I have to worry about is that term right there, the negative 3x to the 4th. And what are the things I'm looking at in that term? Yeah, I'm looking at the power and the coefficient, right? If the power is even, such as 4, like this, they're both going to be going up like this or down like this, right? Now, since the coefficient is negative, which one is it doing? It's going down. So it's this one right here, right? So they're both going down. So as x goes to the right, what's y doing? As we go to the right, you guys, what is y doing? It's decreasing. As x goes to the left, what is y doing? So we write it as x approaches positive infinity. That means as x goes to the right, y approaches negative infinity. It's going down. And as x approaches negative infinity, that means as it goes to the left, y approaches negative infinity because it's going down that way too. Okay, you starting to get this? Okay. If you don't get this, go home and watch this wonderful video. Okay. What's going on back there, Jay? He wasn't talking to me. Okay. Jay, what's going on back there? Hey, you guys, I'm going to give you a hint, too. On the test, I'm going to give you a different kind of function other than power functions. In other words, polynomial functions. I might give you a reciprocal function. I might give you an exponential function. I might give you an absolute value function. I might give you any of those functions. I want to know the end behavior of those. If you're not sure, graph it and look at it, okay? All right, here we go. Next one. I want you to find all the local maximum minimums of the following equation. Y equals negative 2x cubed plus 6x squared plus 2x minus 12. I just made this function up. I don't know how well it's going to work. I want you to find the maximums and minimums. Find maxes and minimums. Maxes and mins. I want you to tell whether they're local maximums and minimums or what's the other word? Absolute maximums and minimums. Okay, relative maximum minimums and then absolute maximums and minimums. What did I say? Local. Well, that's another way they say it too. It's local to an area. Okay? Okay, but I used the word relative with you guys before. Okay? I'll give you a few minutes to work on that one. Okay. I'm going to have all number 2s. Show me what you have. Okay. All of you raise at the same time so I can compare your answers because I don't know what the answer is yet. All number 2s, please. Is that not, we only got one person done? That's a number 2? You need another minute? Okay, let me compare you guys' answers. Okay, good. You guys are a little bit off on your second one. Okay, who else has got one? You two are a little bit off on your second one. Okay. I think that's what they had. Pretty close. All right, anybody else? Okay, I'm going to put this in the calculator. Negative 2x cubed plus 6x squared plus 2x minus 12. I'm going to graph it on a standard window. Hit zoom 6. Okay, since this is cubic and it has negative right there, I know the end behavior is going to go up to the left and down to the right. So I know it only has 2 minimums, 1 minimum, 1 maximum. I've got to take my window down, don't I? What did you guys go down to on your Y min? Negative 20. And I'm going to put the Y scale at, oh, whoops. I'm going to keep that at 10. And I'm going to go the Y scale at 2. And I'm going to graph that like that so I can see the minimum and the maximum. Okay? All right, so I'm going to hit, if you remember right, you got to go get the calc menu, which is above the trace button. So you hit second and the trace button to access the calc menu. I'm going to find the minimum first, which is 3. I need a left bound on that minimum. That means I have to go to the left of where the minimum is. The minimum is that low point right there. It's asking me for a left bound. I go to the left. I hit enter. It marks the left bound up there at the top with an arrow. Now it's asking me for a right bound. I mark that with another arrow. I know my point is in between it, and it's asking me for a guess now. So I go to my guess, and I get that number right there, negative 0.15. Okay, so there's a min at negative 0.15, comma, negative 12.16 if you round it to the nearest hundredth. So I saw some answers that were just a little bit off that. So I'd like you guys to round it to the nearest hundredth on the test. Got that? Okay, then if I want to find the maximum, Andrew, why don't you just go to the table? You could go to the table, but let me ask you what you got for your answer. 0, negative 12. That's why you don't go to the table, because I got negative 0.15, and 0 is close to negative 1.5, but not close enough for what we want. Depends on what you want, okay? And 12 is pretty close to 12.1. Negative 12 is pretty close to negative 12.16, but not close enough. Huh? The table, because it depends on what, if you go to your table, like right now, if I went to my table, second graph, and I went to the table right there, I could go to negative 12. I can just keep, oh wait, what is it? Negative 0. If I go to 0 right here, it depends on what I incremented in. Did you change your table set to increment it in smaller numbers? See, you're at 0 and negative 12. It's pretty close, but it's not right there. If I set my table in tenths, like if I went to second and my table set, which is above my window button, I can set my table start at 0.1. Oh, I'm going to go at 0, and I'm going to do my table increments in 0.1. But still, that's not going to be, that's only going to get me to the nearest tenth. So when I hit the table now when I hit the table, I can see that negative 12.14, that's pretty close, but not quite, okay? So a table can help you get close, even if you keep narrowing it down. You can go every 0.15, too, on your table and try it that way. Or every 5/100, 0.05 on your table, and you can try it that way. But that's why we don't do it. Okay, second, and table trace, and we're going to go get a maximum this time, you guys. So we do that, and we're going to go back up here, and it's asking me for a left bound. Am I left to the point, you guys? My cursor's to the left. I mark it. Now I go to the right because it's asking me for a right bound. I mark it, and I go back up for a guess, and it will give me 2.15, comma 0.1584. So my max is at 2.15, comma 0.16 if I'm rounding it to the nearest hundredth. You guys, that's what we want to do, is round it to the nearest hundredth. Maddie, you want to go see what you need? They want you down in the office real quick, Cannon's office, and see if you can come back up. Okay. Any questions there? Yes. Oh, that's a good question. Well, actually, this does not have any absolute maxes. Why not, you guys? Because it keeps going up forever. So these two, the max, this is a relative max and a relative min, because they're not absolute highest points on the graph, but they are in their local area. They are the highest points. Okay, does that make sense? It's kind of like having a mountain with lots of different peaks. You might be on top of a peak. You're at a high point, but is it the highest peak? You know, you can see something higher? No, right? Okay, any questions? Okay, are you gone for the day, Maddie? You might want to watch this video if I can get it up to get the rest of the review. All right, next question. You guys all know how to find maxes and mins now? Because that's on the test. Oh, by the way, let's go back to this last problem. Now I want you guys to find the intervals on which this function is increasing and decreasing. That's the next question. What intervals is the function increasing and decreasing? Okay, I'm going to give you a second to work on this. Okay, we're talking about the intervals on which it's increasing or decreasing. And to do that, we have to look at the graph as well as look at where the mins and the maxes are. And remember, increasing and decreasing, we're talking about an x interval on which it's increasing or decreasing. When you describe whether it's increasing or decreasing, you're telling what the y value is doing. So your intervals are x numbers. Got it? So if I'm looking at this first one right here, I'm looking at the graph. This graph, as you come from negative infinity, if you come from the left, in other words, the y values are going down, right? Until you get to where along the x-axis? Okay, so this function is, and I'm going to go to the next one, this function is decreasing on the interval negative infinity to, what was it, negative 0.15? That's the x value of this minimum point right here, right? It's decreasing until you get right there. Then the y values start to increase as you move to the right more. From negative 0.15 to where, you guys? Increase from negative 0.15 to where? 2.15. So everybody got that? As from negative 0.15 to positive 2.15, the y values are going up. They're increasing, right, Easton? Okay, then, okay, this function is decreasing from 2.15 to where? Positive infinity, to the right, okay? 2.5. As you move right, the y values are decreasing. As you move right, as x moves right, y values are decreasing forever, okay? And so these are the intervals on which this function is increasing and decreasing. Yes? Because we're talking about the x number. As you go to the right, that's positive infinity on the x, right? Your y values are decreasing. Does that make sense? Okay. Anybody else have questions about that? How many of you think you understand this now? Okay. If you don't understand this, I would suggest watching this video, if I can get it up, or at least going back. I'll put this as a PDF too on the website like I normally do, so you can look at the notes. But you guys, the next test is going to be tough. Okay? If you don't understand this stuff right here, it will be tough. Got it? Okay, I want you guys to get this. All right. There are going to be two problems where you have to find maximums and minimums and then tell whether it's increasing or decreasing. So that's total 4 problems, 2 problems on each one. Okay. Now, we still need to know how to do the next one right here. I want you guys to find, okay, everybody turn your heads. I'm going to put a function in here. And I'm going to put it on a standard window. Okay. So you can look now. Okay. Find the equation of this function. There will be 3 problems like this one on the test. Find the equation of this function. All right. Well, some of you guys have the correct answers, but let me just go over this one really quickly. This, first of all, you guys, what kind of function is this? It's a reciprocal or a rational. It's 1 over x, right? Keep in mind that there's a focal point. If I draw it on here on this, my thing's a little bit off, but it should be right in the center of all that. I can move it over here, right there. Okay, but it's right in the center of that. So I moved my focal point. How far? Which way did I move it? To the right. How far? So how do I make it move 5 units right? I go x minus 5, right? And that's going to shift it to the right 5 units. And then it moved up, how many units? 3. So I add 3 to the function, and there it is. Easton. The thing in between bigger. What do you mean? Are you talking about where you stretch it or shrink it? Yeah. In other words, put a number on top other than 1 in this case? No, I won't do that on the test. I'm not going to stretch or shrink it. I'm not going to multiply it by any numbers, you guys. I'm just going to do, I might do, the only 3 things I will do is reflections, horizontal shifts, and vertical shifts on the test. Okay? You guys ready for another one? Turn your heads. Turn your heads. got to do that. Okay, you can look that one right there. See if you can get that one. All right, everybody show me what you have. I want to see how many of you got it, because this one's easy for me to check. Got to put a y in front of it. I believe that's a 1. You're supposed to x plus 1. Okay, that's correct. Correct, 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 correct. No. You got to put the radical over the whole x plus 1. Okay, correct. You guys, this one right here is shifted. First of all, it's a square root function, right? So that's the parent function. It was reflected over the x-axis, so we have a negative x. It shifted to the left 1 unit. We do that by replacing x with x plus 1, so the whole x plus 1 has to be under the radical. And we shifted it down 3 units, so we minus 3 from it. Got it? Okay, those will be on the test. How many of you feel comfortable doing those kinds of problems? If you don't, I would go home and practice these. I'd look these back up again and practice those problems right there. Okay, now, the next problem that we need to talk about is writing an inverse, or finding the inverse of a function. I want you guys to find the inverse of this function right here, or of this graph. I want you to find the inverse of that graph right there. Graph it. I want you to graph it. Michaela wants me to give the points. I will do that. That's a good idea. 2 comma negative 9. 1, 2, 3, 4, 5, 6 comma 1, 2, 3, 4, 5, 6, 7. 6 comma negative 7 and 9 comma negative 1 are the points, and I need you to graph the inverse. Graph the inverse. Okay, so on this one right here, to find the inverse, all we do is what? Switch the x and y. And so instead of 2 comma negative 9, we are going to graph negative 9 comma 2. So negative 9 comma 2 is on the graph. Instead of 6 comma negative 7, we're going to do negative 7 positive 6. Right? Negative 7 comma 6. Hope I'm counting right because I was talking while I was counting. 9, instead of 9 comma negative 1, we're going to do negative 1 comma 9. And so we're going to get this graph that looks like this. Now, if you remember right, the line y equals x, which is this dotted line I'm making, y equals x, a function and its inverse are always reflections over the line y equals x. Any questions there? Can you do one like that on the test? Okay, there's going to be one like that on the test. Next problem. Find the inverse of this function right here. Find the inverse of this function right here. All right, for those of you who didn't get it, watch this. First of all, the f of x is the same thing as y, right? How do you find an inverse? Switch x and y. So I'm going to switch x and y. Now you guys remember? That's how you find the inverse? Okay? And then I have to solve for y. So I'm going to add 6 to both sides of this function. That's going to give me x plus 6 equals negative 3y. And then I am going to divide by a negative 3. Okay? Well, these 3's are going to cancel out. I'm going to rewrite it up here. Y equals negative 1/3 x. Why is it negative 1/3? Yeah, because this is a 1 in front of that x. 1 divided by negative 3 is negative 1/3. And 6 divided by negative 3 is negative 2. Now, I'm going to use inverse notation, which is f inverse of x equals negative 1/3 x minus 2. Do we get that? Okay, that is inverse. That's how you find an inverse. Okay, the next problem. The last type of problem that we're going to do is I'm going to give you guys an equation where you have to find, I'm going to give you rational functions. Okay, let me give you one right here. All right. I'm going to give you the rational function f of x equals 4x cubed minus 6x plus 2. And I'm going to put that over. You know what? I'm going to change that to 4x squared minus 6. And I'm going to put 2x squared plus 3 on the bottom. And I want you guys to graph that. First of all, I want you to find the vertical asymptotes and then find out if it has any horizontal or slant asymptotes. And then graph it. And you can use those 6 steps that were back on the back of that worksheet I gave you that shows you how to graph a rational function. If that would help you, I think it would help. Actually, yeah. Guys, for the sake of time, I got to go over this one. First of all, how do you find any vertical? It doesn't have any vertical asymptotes. I made this one a hard one for a vertical asymptote. Actually, all you have to do is set 2x squared plus 3 equal to 0, right? You're going to minus 3 from both sides. And then you're going to divide by 2. Now let me ask you this. Is there a number you can square and get a negative number? There are no vertical asymptotes. You can't make the denominator 0. No vertical asymptotes right here, okay? So no vertical asymptotes. Okay, how about horizontal or oblique? What does it have? It's got to be horizontal. At where? Y equals 2. There's a horizontal at y equals 2. How can you tell? And how do you know you do that? Yeah. If the power of the numerator, which is 2, is equal to the power of the denominator, which is 2, you divide the numerator coefficient by the denominator coefficient of those terms. So 4 divided by 2 is 2. So y equals 2 is your horizontal asymptote. Actually, on the test, you guys, I was just looking, you don't have to graph it. All you have to do is be able to find, but I'll give you a hint. You have to find a slant asymptote on there. Remember we reviewed those last time? You need to know how to find a slant asymptote. And I can go over one of those before we take the test on Monday. I'll just do a little, I'll be answering questions. Now, I gave you an assignment last time. Don't forget about that assignment. I will go over those questions on the assignment next time before we take the test, but I'm not going to have time to go over all of them, just some of them. Study for the test. It's going to be a doozy. It's going to be most of your grade for this quarter, just so you know. Study. Watch this video if you need to. Okay? Oh, yeah.